Welcome back to my guide. We're talking about haematology and immunology. Really quick. Hopefully you can ride along with some of this stuff. So, when we think about blood, we all know blood. We know what it looks like. We've seen it in horror films and things. But actually the question now becomes, what is blood? So blood is basically two things. Plasma and formed elements. So what is plasma? Well, plasma is fluid into which things are dissolved or not dissolved. So it's basically a substrate into which things are, in the same way that seawater holds fish and sharks and starfish and turtles and all that jazz. So plasma holds electrolytes, proteins, carbohydrates, fats, and the like. So it holds a whole load of things. So it's really, really important. It also holds these things called formed elements. So formed elements are cells that we consider to be a tremendous amount. I mean, this is, the formed elements are basically haematology and immunology. And they're split into three things. They're called WBC, RBC, platelets. So WBC is white blood cells, or white cells, and these are your immune cells. And your red blood cells, also called erythrocytes or red corpuscles. And your red blood cells, many things, one of the main things, oxygen and carbon dioxide transport. So that's the reason why your blood is red. That's the reason why you are able to carry oxygen and carbon dioxide. And without a constituent of the red blood cell, which we won't go into, but you'll go into in a lot more detail later on, without the constituent called hemoglobin, we actually wouldn't be able to carry sufficient oxygen just dissolved in our plasma. So we need this cell to make the process more efficient, to make it much better. Okay? Otherwise, the plasma alone would not be enough to sustain life. So very quickly, derangements of red blood cells, such as a drop in them, which can cause anemia, certain types of anemia, there are many types of anemia, can quickly take hold and cause big problems. So that is a quick rundown of blood, plasma, formed elements. If we take a tube of blood and we stick it in a centrifuge, spinning, 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 what happens is a process called fractionation. And fractionation splits. Boom. Once we've stopped stirring up the whole thing, what we'll have is three different layers. Okay? We'll have a yellow layer at the top. I don't have a yellow pen, use your imagination. And that's the plasma. So your plasma is sat at the very top. The heavier things, the formed elements, are down below. So at the bottom here, this big bulky thing, are your red blood cells. And then this thing is called the buffy coat. Okay, it's like a fluffy sort of like foam on the top of your pint glass. Buffy coat. And your buffy coat contains everything else. So we're thinking our white blood cells, and we're thinking our platelets. Okay? Buffy coat, white blood cells, platelets. This, in a nutshell, is blood. Hematopoiesis, that's what it's called. Hemato, meaning blood. Poiesis is to make, from the Greek to make. So we are making blood. Where do we make blood? Well, at different points in your life, it's different areas of the body. BRB. Here's a long bone. This is our tibia, which we've met before. The outer portion of it is nice and hard, but if the whole bone were this, it would be very brittle, snap, and very heavy, so we have a bit of a cheat. The centre of this cavity is completely hollow. So if I were to take a slice of this, zoom, and were to look down, we would see this. So we would see the outer portion, which is called the cortex, and cortex will be something you'll see over and over and over again. So in the kidney, for instance, the outer portion of the kidney is called the cortex because it means bark. And the outer portion of the cerebrum, the exact same thing. So we have the cortex, and this inner layer, the inner sanctum is called the medulla. It's hollow, except for something called bone marrow. Now, I'm sure you've heard of the term bone marrow transplant and things. So, bone marrow is this marrowy, gooey thing in the centre of your long bones. So, inside this tibia, there's some bone marrow. Okay? Well, this one's plastic, we get the drift. Right, so, hematopoiesis. So, in the beginning, there were stem cells. So stem cells have the ability to become many different types of cell. It is just a cell that has not specialized yet. Okay, it's still a junior doctor. It's not specialized yet. So in this light, it can become a number of things. Now, the very first thing it will do is choose a broad genre of what it goes to. So instead of doing its GCSEs, it's decided to make its A-levels. So it's sort of starting to shoehorn its way down the thing. You know, it's dropping French. It's not that interested. So in this light, it's going to start to become a little bit less potent. There's a few things it can't become. So we're in the marrow here, and this is where this all-knowing stem cell sits. And it can join the M line, or it can join the L line. You have to move the shadow a bit. So the M line is called the myeloid line. Myeloid line. And the L line is called the lymphoid line. Now, you may have heard the terms myeloma, lymphoma. So this will be cancer of the lineage of these different types of cells. So, what have we got so far? Quick recap, because it can quickly become quite confusing. We have a long bone. Within our long bone, humerus, you have an outer cortex, inner medulla. Within that medulla is the bone marrow. Your marrow contains the stem cells, which can join the M line or the L line. Now, the M line can become a ton of things. So, the quick and dirty trick is, if you learn the L line, everything else is myeloid. If that was a question on an exam, for instance, wouldn't that be nice? So, L line, let's start with this. So the lymphoid line is going to make lymphocytes. Okay? So we start with, it can basically go two ways. It can form something called an NK cell, a natural killer cell. Sounds quite ominous, it is. It kills basically almost everything. It can go after cancer cells, it can go after viruses, bacteria, the lot. It goes after a lot of things. Okay? And it's one of the first line defenders for a generalist response. Something is here that shouldn't be here in my body, let's get rid of it. It's a natural killer cell. The other thing it can become is a small lymphocyte. Now let's sort of delve into what this means. So small lymphocytes, we can bifurcate this process a little bit further into a B cell and a T cell. And this nomenclature, this naming, is named after where they undergo the next stage of development. Okay? So if this is the college, where do they go to uni, basically? So B cell is a cell that stays in the bone marrow. It stays in the bone. T means thymus. Now, what is the thymus? Well, the thymus is a gland that sits on your heart here, sits on your heart, on these vessels here. Sort of mid-adolescence sort of phase, it starts to be full of fat and loses a lot of its power. Okay? So you get big changes to the immune system, which will be explored in medical school for obvious reasons. But the thymus gland, yeah, that's where it is. So B cell, T cell. Now your B cells split further two ways. They split into plasma cells and memory cells. So a B lymphocyte, or a B cell, giving us a plasma cell and a memory cell. Now, our plasma cells secrete things called antibodies. Antibodies, abbreviated to AB. What is an antibody? Well, you could do a whole module on what is an antibody. But basically, if I have a B cell here, it's patrolling along, and then I have a baddie here. So, some kind of baddie here. And the baddie has characteristic bumps on its head, like so. Well, my B cell makes something called an antibody, which, as it happens, fits on this baddie very specifically. So my B cell starts to make a ton of these little things called antibodies, which are antagonistic to the body of this pathogen. Okay, so they will bind to these things, bind to these regions. There's a whole load of names and different kinds of things that you will go into in your immunology lectures in much more detail. So don't worry about that. This is about overall concepts, so you have something to scaffold onto. These antibodies bind to these things called antigens, a specific region of the antigen called an epitope. And when they bind to them, they trigger an immune response. So basically, it's kind of like coating something in, like some delicious syrup. Your immune system, the other cells, will go haywire when they see this coated baddie as opposed to a normal baddie. It makes it much more desirable to be attacked. Okay, so that basically in a nutshell is what an antibody is. Now let's have a quick look at memory, kind of what it says on the tin. It's sort of your basis of vaccination. So you ever wonder how you're vaccinated against something like polio and then you never get polio? Well, you could be exposed to polio, but this shot has trained your immune system to be able to respond quicker, to be able to respond earlier and better than the initial time, because it remembers, it learns, it remembers how to respond to these baddies. And that memory, that knowledge of the best way to take out a baddie it's seen before is stored in B cells, the memory cells. So what about T cells? Well, there are two different types. You've got TC and TH. The C stands for cyto, which means cell, toxic. Cyto, toxic. And the H stands for helper. So a cytotoxic, cyto meaning cell, toxic, have a guess, and then helper, have a guess. So your cytotoxic T cell will actively, like an NK cell, go out and kill them. Now, your helper cell is all about helping a response. It's bringing in the good guys to come and help. It's making the good guys who are there attacking the bad guys, it's making them more useful, more powerful, lasting longer, and better able to understand their enemy. There's a whole lot of signaling and processes and talking to other cells going on. A phenomenally complex thing that, you could do 3 PhDs in immunology and still have no clue what's going on. Very complex, also very interesting. Okay, that's your lymphoid line. So NK cell, B cell, and T cell. There are 2 B cells, there are 2 T cells. We'll take a break here. Welcome back. We're nearly there. Now, your myeloid line, the M line. We've done the L line, we'll do the M line now. So this line forms a few things. There's loads of steps involved. You'll learn about some, but honestly, unless you're going to do like advanced hematology modules or become a hematologist, don't, just don't. Red blood cells, platelets. We can also make something called a mast cell. And we can also make something called a monocyte. We have another one here. And the reason I put these 3 together is because they're classified as the same subfamily, this myeloid line, and they're called the granulocytes. Granulocytes. Now what do I mean by that? So what I mean by this is, if you have a cell, you normally have a nucleus, as John has done with you, And you might have some vesicles or lysosomes, a storage container within the cell that contains things. Now, granulocytes are such that on some common dyes that we use, we wash dyes over and then we look down with a light microscope. On some of the dyes that we use, you can actually see the contents of the granules stained brilliantly in oranges and yellows and purples. Some of them look pretty cool. So you can see quite a lot of them going on. So they've been called granulocytes because they're just so striking and they can be differentiated based on their granules. And that's these three. You have a basophil, an eosinophil, and a neutrophil. Dead easy to remember, B-E-N, then the granulocyte. Right? So, a brief nod to the functions of each. So red blood cells, dead easy. Red blood cells transport oxygen and carbon dioxide. We've said that. Platelets, clotting. So when you bleed, there's loads of things that go on, but the very initial step is, here's an artery, here's a break in that artery. So our blood, again I'm going to green blood, so our blood that's running through here will also leak out of here. So the very first step, before you fix the wall, and before you fix all the damage and the underlying causes, you need a very bog standard plug that will sit there and will block it off. These platelets that are floating around as formed elements within our blood coalesce together where this hole is, boom, and form a plug, a rudimentary temporary plug that's blocked. And then a whole load of chemical clotting cascade processes come together to reinforce this clot and to integrate it into the newly fashioned wall like this. Okay, that's the role of platelets. Mast cells, we're not going to say much about those except they're a cell that has granules, and when they release these products into the environment, these granules trigger an allergic response. Okay? If you've got hay fever, your mast cells don't like your own. Okay? So mast cells, you see them in allergy. So, monocytes. What do monocytes do? Right, so, let me give you a scenario here. Here's a blood vessel. Let's say it's a vein. And let's say we've got a bacteria. We've got a baddie in here. Well, I want you to think of the monocytes sort of like, the police. Bobbing around in the car here. Minding their own business. And driving around. They're not doing anything. Just sort of driving around. There's no sirens on, whatever. This is a monocyte. It's a sentinel cell that's bobbing around and looking for trouble. When it finds trouble, let's say this bacteria is actually in a break in the wall over here. There's a bit of a break in the wall here. Well, this monocyte drives up to here and then differentiates into a killer. It differentiates into a macrophage, or macrophage, which literally means big, eaty thing. Because a phage, a phagocyte, is something that gobbles. And it literally gobbles. It's bizarre. You can see them on, you can Google some little YouTube videos about these things, and they're very weird. So if the bacteria is like this, what it will do is, it's a giant cell. It's a macrophage. Here it is. And it will just extend out its body around the bacteria and then contract the body in and completely engulf the thing. And then it has granules full of very horrible stuff like hydrogen peroxide and things that it will inject directly into the bacteria once this bacteria is inside the macrophage itself, causing the bacteria to shrivel up and die, and then it will recycle the bits of the bacteria that it can for its cellular process and excrete into the plasma bits that it can't. Very bizarre thing going on. So that's a macrophage. And we're almost done now. So, a basophil is pretty similar. Basophil, allergy. So basophil and mast cells, they're very, very similar. Eosinophil, parasites. Parasites and to regulate a basophil. What about a neutrophil? Well, a neutrophil is actually, as it happens, a phagocyte. So a neutrophil will work in concert with a macrophage. It doesn't need to differentiate from a monocyte to a macrophage there. So sometimes a neutrophil can be a quicker response. It's also a big proportion of cells. It's about 60% of all of these cells that we've named so far. There's a lot of them basically, so it's a very influential cell. But it's basically just a phagocyte. So, stem cells form the L line and the M line. The myeloids become red cells, platelets, mast cells, monocytes, and then the granulocytes. Basophil, eosinophil, neutrophil. So, here's the thing. Leukocytosis. Leukocytosis means leuko, white, cytosis, an abundance of cells. Okay? So leukocytosis, we've got an increased white cell count, which you might get on a pathology report, you might get some labs back. Increased white cell count. So we say, okay, what's raised? Well, eosinophils are raised. Okay. So in this case, if our eosinophils are up, then we have what's called an eosinophilic leukocytosis, which sounds like a mess, but actually unpack it, it makes sense. Eosinophil, eosinophilic, philic, yeah, so lots of them, they like it. Leukocytosis, lots of cells that are eosinophils. Eosinophilic leukocytosis. So this either means we've got a parasite going on, or we're regulating basophils. So what's a really quick and dirty way to find out? Well, look at your basophil number. Okay, basophil number's normal, so it's probably not an allergic reaction that's being regulated by eosinophils, so therefore it's more likely to be a parasitic invasion. So you can see how a lot of questions in exams can be formed based on this number's up, what's the consequence, or this number's down, what do you think might have caused that to happen? So that is the hematopoiesis tree, and we'll take another break. So I don't want to spend too much time on this last section. There are two arms to the immune response. Okay, so you've got that bacteria in your body. It needs to die. It just needs to die. So how are you going to kill it before it kills you? Well, we talk about innate immunity, and we talk about adaptive immunity. And we're going to divide both into the easiest way that I can think of to divide them into. Cellular and humoral. Now this comes not from the humour of the bone, but it comes from back when the very original physicians, Galen's time, they thought that it was the four humours, 4 different substances that were floating around your body that you had to keep in lockstep together, hence bloodletting if there was too much blood kind of thing. So the 4 humours. So humoral, just think of it, humoral is a substance that is floating around in the blood that isn't a cell. Okay. Does that make sense? So that's what it is. So cellular and humoral. So we have cellular and humoral. Still a very often used term that's very archaic, as is so much of medicine. So, these are the 2 different things. Just will show. Okay, so let's put some cells in of the innate immune system. NK cells, macrophages. What's the best friend of a macrophage? A neutrophil. And then Ben. So our granulocytes, basophil, eosinophil, neutrophil. And then humoral, loads. And I'm going to put acute phase protein. And I'm going to put complement. Now, each of these nodes, because my month I'm writing in red, could have a lecture. So again, very basic principles to introduce you to the vocabulary so that when it's mentioned in a lecture, you can start to already recall and make connections. So, innate, cellular, natural killer cells, granulocytes, macrophages, and neutrophils. So these cellular things are the innate response. They are first line, they are there already. Okay? They're not some specialist task force that's being assembled. They're already floating around in the body. They're just going to attack when they see anything that they deem to be foreign. Okay? This is not a targeted approach. This is broad spectrum. I don't like that being here. Go for it. Okay? So that's what these guys do. And we've already defined their function. So humoral, acute phase proteins. Let me say. This organ, the liver, secretes a lot of acute phase proteins. What is an acute phase protein? There are a lot of them. They have a lot of discrete functions. But let me answer that in a single sentence right now whilst you're learning the very fundamentals. An acute phase protein is a fire alarm. There is an infection in your little toe, but we need the whole cavalry to come down and charge and get it. What do? We trigger the fire alarm. The liver, which makes so many things, it has over 500 discrete functions. It's incredibly complex and it's seriously underrated by lay people. Very important. It secretes a ton of these acute phase proteins. The fire alarm is triggered across the whole body. That's what these are. And we can look in blood of a patient to see if the acute phase proteins from the liver are up or down, which is indicative of some sort of inflammatory response. Okay? Which could mean infection, it could mean autoimmune. So let me put the liver here. So, acute phase protein, so we're thinking liver. Complement. So complement, you're complementing something. Oh, that's very nice. For complement, this is a bacteria. Complement is a series of proteins and things that bind to and just make something more delicious. It's sort of like those antibodies before. They will bind to the baddie, make it more delicious, make it more likely for macrophages and neutrophils to come and gobble it up. So that's the cellular and humoral response. What about the adaptive response? Well, I think you can sort of guess what this might already be. Cellular are our TC, and humoral is our T helper, and our B cell. So it's nothing new. It's stuff that we already did at the start of this seminar. So cytotoxic T killer cells. These are adaptive things. These are things that are tailor-made to target this specific baddie. So when they get there, they're like a heat-seeking missile. They are so much more accurate and effective than these guys, but it can take days to weeks for them to get there. It's a very adaptive, slow-running response, particularly the first time. So the next time the immune system is battling that baddie that it has encountered before, you have your innate immune system. What is it going to do? It's there, it's battling, but it's non-specific, so it can be being overwhelmed. It's like, where on earth is this adaptive immune response? Well, now that the adaptive has encountered it before, because of our B cell, because of our memory cell, its response comes sooner, it is more powerful, and it will last longer. So 3 things that are so much more advantageous, to such an extent that quite often you won't exhibit any symptoms. Because the adaptive response is so strong so quickly, the body takes care of it before it starts causing notable changes and damage to the body. And that is hematology and immunology. And 3 Oh my god, that was the last word.
Different one.
Longer, faster, more powerful. Longer, faster, more powerful. Yes.